Hello, welcome to this video on reflecting a line in a plane. This is for the Edexcel Further Maths syllabus, and I've taken the question from the Core Pure Mathematics book, Year 1 AS book, and it's exercise 9F, question 12. So here we've got this vector equation. There's the line, there's the plane. I'm going to reflect this line in that plane. Might be a good idea to see visually what we're doing. So there's a plane, there's our line, and it goes through the plane. Call that L1. Now L2 would be like this. They'd meet at the same point on the plane, and here, well, we could see a reflection there. I'm going to use that type of line later. First of all, I'm going to find that point there. I'm going to call that M, just because it's where it meets the plane. So what I do is, I imagine R is some point on the plane, which is also a point on the line. So the general point on that line I can write as 2 plus 4 lambda, negative 1, take away 3 lambda, 2 plus 4 lambda, dot 1, negative 1, negative 1 equals 4. So, well, I can just expand all of that. 2 plus 4 lambda, negative 1 times 1, 1 plus 3 lambda. Be careful with the negatives. Take away 2, take away 4 lambda equals 4. Lambda, 3 lambda, take us, I think I've got 3 lambda there. 2, 3, 1 is 3. So I should get, I think, lambda, yes, lambda equals 1. So what that means is this point is when lambda's 1. So 2, I'll just write the coordinates of that point. 2 plus 4 is 6. Negative 1, take away 3. Negative 4, and the Z is 2 plus 1 lot of 4, which is 6. So that's where the lines meet each other on the plane. Now I'm going to get a point on L1. A good enough point to get on L1 is the jumping on point. 2, negative 1, 2. I want to find this point here, which is a reflection of that point in the plane. Now there will be a reflection of a coordinate in the plane which will be on the line, which is a reflection of this. So I need this. Now I'm going to call this P, I'm going to call this Q. Now the line PQ has, I know, a jumping on point of 2, negative 1, 2 is a good jumping on point. I also know it's in the direction perpendicular to the plane. So I can say just any parameter there, just call it mu. Mu 1, negative 1, negative 1. So that is the line PQ, and I'm going to try and find that. First of all, I want to find when that meets the plane. So I do the same as I've done before. 2 plus mu, negative 1, take away mu, 2 minus mu, dot, and then the direction of the plane. Remember that this equation here, I'm using this, 1, negative 1, negative 1. Equals 4. So I'm finding, if I extend that plane out a bit, I'm finding this point here, or how to get to that point. So let me see this. So I've got 2 plus mu plus 1 plus mu, take away 2 plus mu equals 4. I put my mu's together, I get 3 mu equals 2, 3, 1, take away that is 3. So mu equals 1. So I know, well, I can say what that point is. I know that point is going to be here when mu's 1. So I suppose it would be 3 minus 2, 1. So what's this point going to be? Well, let's have a look. This is halfway. This is my halfway here, halfway between P and Q. Halfway between P and Q. So Q has got to be 4. Then this will go another negative, so I'll have negative 3, 2, 1, and that's got to be 0. So by finding where this perpendicular from Q meets the line, I can then go further to find the reflected point. Now I know my line, which is a reflection of L1, this new L2, goes through 4, negative 3, 0. So it goes through Q, which is, goes through Q, which is 4, negative 3, 0, and it goes through this midpoint of M, the meeting point, of the line. So I know my meeting point, M, is going to be 6, negative 4, 6. So I can then find an equation. Well, let's think about how do I get from Q to M. Well, from Q to M, I can clearly see I'll go 2, negative 1, up 6. So I just choose 1 as my jumping on point. Let's say Q. So my new line, this L2, which is reflected, is now 4, negative 3, 0, plus, let's use T as our parameter now, T, and QM 2, negative 1, 6. Let's just review what I've done there. I've first taken the equation of the original line and the equation of the plane. I found where they meet by substituting in my general point on the line. So I know this. I've then taken a point I know is on the line, which is the jumping on point from the equation, and I've reflected it in the plane using the technique you did earlier in this chapter. So I know Q is going to be on my new line, and I know M is going to be on my new line. Once I've got those, the job is done. Now, I think that's quite a tough question. I hope it's clear. Thank you very much.